This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Oh yeah, no problem. Looks like I'll still be loading up when we start. All right. Okay. So the next topics in these in this lecture is going to be looking at the dangers that we face with the process of producing and also consuming food from food-producing animals. Okay, so I think it's important to keep in mind that we consume food from food-producing animals, but often there's a discretionary aspect of that. For those that might be vegan or vegetarian, you might say, well, of course there's a discretionary one. You don't even have to eat any of these, and that's true. But also which particular ones we choose to eat too. There's a fair bit of discretion there. So I guess one of the things we should be thinking about is if there's risks and we're supposedly eating this food for some of its health benefits, then should we be doing that? And perhaps there's a certain amount of weighing up to say, well, should we take the risk of eating these things unless we can be assured that on the balance there's good positive benefits of eating this food. I guess you could say it just tastes good anyway, and so I'll take the risks. But certainly we'd like to be thinking that if we're eating these products, that they're actually healthy and they're not harmful to us. But that's not always the case. Okay, the number one cause of food poisoning that comes from animals is Campylobacter. There's a number of species, but mainly Campylobacter jejuni. And this is a fairly common bacteria that is in fact found in cattle, pigs and poultry. Now, this is an organism that they carry in their digestive tract, but for most of those, it's completely asymptomatic. So they have this as part of their normal flora. The normal bacteria that are in the digestive tract of these animals includes these particular bacteria. So it turns out they're fairly well adapted in there, or the other way around, the bacteria are pretty well adapted to those particular hosts, and everything seems to be okay. So there are occasionally some problems that these organisms can cause to these animals with very young animals, old animals, or animals that are sick. But in most cases, this doesn't seem to be a problem for these particular animals. However, if this comes from the digestive tract and contaminates the food that's produced from those animals, then this can be potentially a major problem for humans. So in the case of humans, we can have, well, the reality is, for some of us, we can consume a food that might be contaminated with Campylobacter, and we may not actually notice something, or we might notice that it's having a mild effect. So the greater percentage of cases are not going to be that severe, but when we do have severe cases, they can be pretty bad. A lot of inflammatory reactions, sometimes bloody diarrhea, which is a pretty apt description of what happens, cramps, fever and pain. That's sort of the typical signs, I guess you'd say, of fairly bad food poisoning. And I guess I should try and sort of look up a more recent statistic to give you, but I don't think things have changed dramatically, but you know, about 15,000 cases in Australia per year. So it's a fairly big problem. And the thing is, this is an organism that really doesn't have any other natural reservoir. So it's not as if it's in the water supply or whatever. Temporarily it may be, but it's basically going to be traced back to an animal, to a cow or pig or to poultry. 97% of cases, human cases, come from livestock. More from chicken than from cattle, but regardless, most of them can be traced back to livestock. Okay, so it can be that you can get it from someone else, but in most cases it's coming from livestock, and in most cases it's because of contamination at the time of slaughter. That means that the meat becomes contaminated with a little bit of fecal content or gut content, and this can allow the organism to breed. The organism will quite happily multiply in the right conditions, temperature conditions, and nutrients provided by the meat or the eggs or whatever. Predominantly, it's going to be meat contamination that's going to be the problem. Okay, so how can we actually prevent that? Well, this is what we do need to continue to work on. Certainly there's been major improvements over recent years in trying to minimise the cases, and it's true that compared to a couple of decades ago, we've made major inroads, and we've certainly reduced the incidence of cases of it. And that's been partly due to what we do with the food. Pasteurisation processes of the food certainly kills the organism. It's not a particularly difficult organism to kill, so pasteurisation processes work. General cooking is pretty effective, but one of the main things we want to try and do is make sure that there's really good slaughter hygiene to make sure that that it's not contaminating the meat when it takes place, and also biosecurity. So if we know that there's sources of the organism in particular groups of animals, that we try and prevent that from spreading to other animals and the like. And there's an article that I'll refer to, I'll give you the reference to, that looks at this issue of biosecurity in order to try to reduce the incidence of Campylobacteriosis. So it's a pretty big one, but it's probably not the one that most people hear about and are most concerned about, which is, I guess, Salmonella. Now, in this particular case, there's some similarity here. There's actually a wide variety of different organisms, Salmonella species and subspecies, that actually take place. So I'm not going to make a big thing of that, but some are more common in pigs or in cattle or rodents or birds or whatever. What we can say in general is that Salmonella as a family contains quite a number of different species, but they are very broadly distributed in a broad range of species. And in fact, most species will have salmonella. And in fact, most individuals in a group of animals or a group of people will have the salmonella organism. And chances are, if we went looking for it, and we're not going to do that little exercise with you today, but it'd be an interesting one, if we went looking for signs that you actually carried salmonella, the chances are a proportion of us would actually have salmonella. Now, the salmonella is typically in the digestive tract, sometimes in the bile duct, sometimes in other areas. But in fact, most of us would be completely unaware that we actually carry salmonella organisms in our digestive tract. A large percentage of us have had salmonella infections in the past. Some maybe more than others, but often we have actually had them. So it's an enteric organism that has a large percentage of carriers. So even if we have an outbreak of it, we'll have some people or some animals that might be greatly affected. We then have a larger percentage of animals and people that aren't so affected, that maybe a bit of a funny stomach and maybe just not feeling all that well, and some that may actually show relatively few signs at all. And then after that, there may be some percentage of carriers. It depends on the actual species and the type of salmonella, but something like about 5 to 10% can be carriers after there's been this infection. So the reality is, quite a number of us have had salmonella in the past, and some of us are actually carriers of that salmonella. It appears not to cause any problems for us, but what we've got to be careful about is it a risk for other people or other outbreaks? And the answer is yes, it could be. So in the case of humans, can be really nasty. Acute gastroenteritis with fever, vomiting, nausea, abdominal pain, headaches and diarrhea and dehydration. And maybe I should have put death there as well, because it can be certainly pretty deadly. And there's approximately about 1,000 cases reported in Victoria. Now, this is really just the tip of the iceberg, because as I said, for a lot of people, they may in fact have a case of salmonellosis and not actually realise that they've had it. So the actual reported cases are the ones where someone's gone to the doctor said, oh gee, this looks pretty nasty, we'll actually need to do some swabs, we'll need to do some diagnosis. And it's actually not always so easy to culture and to diagnose, and so it's quite possible that even if that's done, that it's not picked up. And so that 1,000 is really a gross underestimation of actually how many cases there are. However, the evidence is that the incidence here in Australia has certainly plummeted compared to a few decades ago. A couple of decades ago, it used to be that every year there'd be at least one major outbreak that would probably kill a number of people. There'd be quite a number of people hospitalised. Now, that sort of happens, but luckily not so commonly. A major outbreak seems to occur every couple of years. Now, that's not particularly good, but it's better than having it more frequently, which is the case in the past. For example, last year there was an outbreak. No one actually died in that particular outbreak, which is good. That's also one of the things we can point to say that there's been improvements in preventing deaths, but it's not impossible that we can have outbreaks where there can be actually deaths as well. Now, typically, they're spread via infected meat or eggs. They're the most common things, and eggs in particular can be a bit of a worry. Now, infected meat, hopefully hygiene is going to help prevent that. But the trouble with eggs, it can spread from the bird into the egg, and then the egg can be then sort of the source of further multiplication of the salmonella. And inside the egg, the salmonella organism can quite happily multiply and multiply. Now, again, one of the things that will safeguard us, and does in fact safeguard us, is in fact cooking. So cooking's a pretty good thing when it comes to meat and eggs. And if we get to 68 to 72 degrees Celsius, And especially with things like soups and gravies, if they get to boiling point, then that's generally going to kill the organism. And freezing kills some, it's not maybe quite so reliable. But if we've got good food processing procedures that involve boiling or cooking, and then that food is consumed fairly quickly. Now, it's all very well to boil it and cook it, and then if we leave it and leave it and leave it for a few hours, then we can have the multiplication of the organisms again. But in most cases, this is actually a major safeguard of us there. And so, unfortunately, that's not always done, or it's not always possible. The last outbreak that we had last year involved mayonnaise. So in those particular cases, it was actually using raw egg and mixing that up. And then, unfortunately, the mayonnaise was left for a couple of hours before it was used. This was at a fairly sort of exclusive restaurant in Ballarat. And so it's sort of, you know, you think, well, maybe if you go to a pretty dodgy place, that's going to maybe have salmonella, but surely a really market one is not going to be so likely. Well, I'm not so sure about that, because certainly we can have cases where even pretty reputable places seem to can occasionally have things. So very important that food hygiene, food processing procedures are done very, very strictly. Now, here in Victoria, over the recent years, I think we've really improved that, and I think the evidence is that when it comes in general to foodborne diseases, we've certainly had a major impact on that. Nowadays, pretty well everyone handling food has done some sort of course. They basically know about the procedures. They know that they need to wash hands, and hopefully they know about the happy birthday to you twice thing, and they realise that they need to do those things. And compliance in these cases is particularly important, and if compliance isn't there, this is where we can have problems. But I think in general we've certainly noticed some improvements. Now, we've noticed some improvements in the actual cases that end up in hospital. That's fantastic. But I think it's even more dramatic than that, because the not so severe cases have become far less common as well. I guess I'm of an age where I can look back at a couple of decades ago, and a couple of decades ago it wasn't that uncommon for a lot of people to go out and go to a restaurant, and quite often the next day they'd go, and presumably this is not because of alcohol consumption, but they go, oh, I feel I've got a little bit of a funny belly. It's been ages since I've really heard many people talking about going out and eating and then the next day having a bit of a funny belly. I think that used to be much more common some time ago. I think we're doing a much better job, but we can do a much better job than that as well. So salmonella is the one that we're most concerned about, because even though most of us can have a salmonella infection and survive it, maybe without too many serious complications, unfortunately a proportion of people in an outbreak of salmonella can be seriously ill and can die. And so therefore it becomes the more serious one. However, that shouldn't mean that we shouldn't be aware of some of the others. Now, for example, Escherichia coli, E. coli. Now, it used to be, not now, but it used to be a while ago, E. coli was sort of seen as a pretty innocent organism. In fact, for general sort of microbiology, it was thought that, oh, well, you know, we can grow E. coli and we can look at that. It's great for doing a gram-negative stain and looking at it. And it used to be thought, oh, well, yeah, E. coli is not too great a problem. Well, it turns out that strains of E. coli can be much more dangerous. Now, E. coli is basically the most common gut microbe for basically all vertebrates. So for vertebrates, if you go looking at the digestive contents and swab them and start growing things, the main thing that you're going to grow is lots and lots of E. coli. It's a very, very common part of the normal flora, the normal bacteria that should be there. And in most cases causes no problems at all for the animal that has that organism. And to be quite honest, most of those species, even if it's taken maybe contaminating food, and then you consume it. In most cases, that E. coli is not going to be much of a problem. However, more recently we've noticed that there seems to be a rise in the more dangerous E. colis that do actually cause disease. Now, I'm talking about E. coli in general, but we'll get on to this particular type of E. coli. But E. coli is basically found in all vertebrates, so birds, reptiles, mammals of all types, including us, have lots and lots of E. coli. And in fact, because it's such a common organism in the gut, we can actually use this as a bit of a measure of contamination. So, for example, I don't know whether you've noticed this, but during the summer, if you want to go down to the beach at the bay and you want to go swimming, one of the things you can actually find out about is the E. coli count of the water there in the bay. Now, I think that's well worthwhile knowing before you have a plunge in the water, because even though we should have good systems of sewerage and whatever, occasionally we can get issues where we can get contamination getting into the waterways and getting out into the bay. Now, how do we know that that's the case? Well, if we take samples of water, we culture that for E. coli, and we find E. coli there, then that has indicated that there's contamination, there's fecal contamination going on in the water. And if it's a certain height, that means there's a fair bit of fecal contamination in the water. Now, those E. coli that are being grown probably aren't the problem, but it's a measure of fecal contamination, and that then gives us the worrying statistic that says, well, okay, if E. coli is being found, even though we may not have cultured it, it means the chances of salmonella and campylobacteria are also much greater. So even if we don't culture those ones, that's not so much an issue here. We know that there's been a certain amount of contamination or whatever. Unfortunately, sometimes sewage gets overflows in some area or whatever, and it ends up that there's some contamination in the bay. And I for one, would prefer not to be swimming with lots of E. coli, and therefore potentially with salmonella or whatever. So in general, we see E. coli as not maybe the major culprit, except when it comes to some serovars. Now, for example, 0157H7 was one serovar that, seems to crop up from time to time. Can be found in cattle intestine, and it can then get in to humans. So if humans then consume this E. coli, severe, acute, hemorrhagic diarrhea, abdominal cramping, signs of a pretty severe food poisoning. Okay, so how can this actually occur? Well, the most common way that this occurs is contamination, again during slaughter, where it gets from the intestinal contents contaminating the food. Perhaps in undercooked ground beef is a great way to actually allow it to get access to the meat that actually will then be the main source of nutrition for it to multiply. An unpasteurised milk. Salamis. Some salamis are made without a pasteurisation process, and this means that if there is contamination, then we can end up with this situation, and contact also with live animals as well. But for people that might be in the inner city, you might say, well, I'm not making any contact with live animals. What are my risks? Well, probably much less, except that you might think that's there's plenty of other ways. Okay, so there's other serovars and other species that are dangerous as well, but I just wanted to mention this particular one because this was a particular one that killed a number of people in Germany back in 2011. And these people were predominantly vegetarian. So here we've got an organism which I've just finished saying is found in the digestive tract of animals. So why would vegetarians be at risk? Well, it turned out that what was putting them at risk was bean sprouts. So there was a batch of bean sprouts, quite a lot of bean sprouts actually got contaminated, that were contaminated with this organism. It turned out that this organism was able to multiply in the bean sprouts. But the question is, if this is an animal organism, how did it get in the bean sprouts? Well, it turned out that the seeds for making the bean sprouts had been contaminated. These seeds had come from Egypt, and there was some tracing done back to find the original source, which is you need the connection with the cattle. So in producing the seeds, there'd been some cattle contamination, cattle feces contaminating the seed in the collection of the seed, and basically been sitting there waiting for the sprouting process to take place. Very few organisms to start off with, but with the sprouting process, that allowed this organism to multiply. So people that were vegetarian were at risk of this particular cirrivar. And as I said, there quite a number of, I think about 6 or 7 people died from that particular one outbreak. So I'm just using that as an example of saying, well, you might say, well, I don't have much to do with animals and I don't eat, I'm vegetarian, so therefore I don't have a worry about this. Well, I think there is some worries about that. Okay, for some people, it depends on your predilections and your tastes. You may put yourself at risk depending on a number of circumstances. And for example, there's a growing tendency for people to want to eat very lightly cooked or even undercooked or uncooked meats. Now, okay, there's maybe some advantages of that, and recently with interest in various various diets that may be supposedly linked back to our ancestors' diets. There is a growing interest in these very lightly cooked or completely uncooked meats. However, there's some risks with this, and one of those risks is going to be that there might, I've just been talking about the fact that with Salmonella and E. coli and with Campylobacter, cooking is a great way to actually remove those organisms. So that's one of the risks, but in some cases there's other risks as well. For example, with pork meat, if we undercook that or we don't cook that at all, then we may actually be having some risks there. Now, this is due to an organism. This is a parasite called Trichinella. So trichinosis is due to infections with Trichinella. Now, this is a nematode parasite. Here in Australia, we don't think we've got it. It hasn't been seen in Australian pork, but it's widely seen overseas. So overseas, certainly pork is found widely overseas to be contaminated with this organism. This organism is found, but it's found predominantly in native animals in Australia, but we don't believe it's got into our pig population. Some people, however, like to eat wild pig. This is feral pig that's been caught. And I think there's possibly some risks there as well. But at this present stage, we haven't actually seen this happening. But overseas, this is potentially quite a big problem and relatively common. Okay, so in this particular case, what happens is the organism, and I won't go into great depth about the life cycle, but the organism has an adult form, but it also has an intermediate form where it goes into various parts of the body. It migrates into tissues, and in migrating into tissues and forming little cysts in the body. This is some tissue. This is some tissue, and you can see these little funny little organisms, and they're encysted in the tissue, in the meat or the tissue that there is. Now, if this happens to humans, if they consume these organisms from the pork and then they consume it, then the organism can then multiply and then spread into various parts of our body as well, which can cause some pretty nasty problems: fever, muscle soreness, pain, gastrointestinal symptoms, facial edema, so your face swells up, subconjunctival, under the eyes you become all swollen, subungual, retinal hemorrhages, which is pretty nasty, so you can go blind from the effects of this, and it's typically because of eating raw or cooked pork. So, I guess the answer to this is either to not eat raw or undercooked pork. The larvae are inactivated by heating or freezing. You can also irradiate the raw meat as well. So there's a number of processes that will kill the larvae, and it'll be quite safe to eat there. You have to actually do a proper cooking process, and if you eat the meat very undercooked, then you're still at some risk. Or we need to make sure that we're sourcing the pork from animals that do not have that organism. As I said, here in Australia, I think we're very fortunate in up until now, we haven't seen this in our domestic pork producing animals. Okay, and I'm also throwing in another one, which hopefully is a bit of history, and hopefully something that we're not going to see much of in the future. But I think it's a big warning of how we need to be on the lookout for potential things that might come from the consumption of food from food-producing animals. And so this is bovine spongiform encephalitis. So, you know, and for example, I just was mentioning about trichinella. Now, I'm saying at present we don't have it in our pigs in Australia, but maybe things will change in the future. We've got to be on the lookout for new organisms that might be causing risk for us, and we also need to be thinking about the processes that are involved. I'll get onto that in a second. The processes that we're involved in with managing these animals, raising these animals, and the possible risks that might arise. Now, this is a good example of what's called an emergent disease. Now, I talked about this last week about, you know, in the 1970s, people said, oh, well, we won't need to worry about bacterial infections because we've got all these antibiotics. Well, what was also thought back in the 1970s is that, oh, look, you know what, I think we've worked out the main diseases for humans and for animals, and, you know, there's a few odd diseases that we had to investigate and find out. But most of the infectious diseases have already been worked out. We already know about them. Well, it turned out they were very wrong. And since then, we seem to have, every now and again, a brand new disease that has never been seen before. And this includes some pretty big ones. So HIV infections, SARS infections, and I can go on. There's quite a long list of human diseases that have suddenly appeared. Now, it's not as if they were there but we didn't know about them. In most of these cases, these are brand new diseases that have, well, they've arrived from somewhere, and we'll talk about how they might arrive, but they've come from somewhere and they've ended up creating a new disease for our species, and in some cases a very deadly disease. And so therefore, rather than say, oh, well, you know, we know about all the diseases that we need to know about, and we can work out all the plans that we have or we need to prevent all those known diseases, I think it's a bit more than that. We've also got a plan for the diseases we don't know about. And so therefore, when we're doing something that seems a bit unusual or different with maybe what we're doing with our animals or what we're doing with our food, I think we've got to think not just in terms of the pathogens we know about, but maybe potential pathogens that we don't know about. And I think that's perhaps the lesson out of bovine spongiform encephalopathy, which is also known as mad cow disease. Not necessarily the greatest name for this, but mad cow disease. And this is due to a very interesting pathogen called a prion. Now, some of you are probably done, who's done some microbiology? We've got some people who've done microbiology courses. So in microbiology, you learn about bacteria and then you learn about viruses. But prions are really interesting things because what is a prion? Well, a prion is basically just a protein. But it's a very unique protein because this is a protein that has some really remarkable abilities. Now, normally what happens if we consume a protein is the protein is broken down by proteases in our body, and we generally only absorb amino acids, which are the component parts of the protein. So we don't absorb proteins, we typically only absorb the breakdown products, the amino acids, of those proteins. But this is a prion that's able to deceive the gastrointestinal tract to allow it to be absorbed through the gastrointestinal tract into the circulation. It then And this is just a protein. It's not an organism. It's not something that has lots of enzymes or various other things. It certainly doesn't have any organs or anything like that. It's just a protein, but a particularly unique protein that then allows it to get into cells. And typically these are long-lasting cells. And the most long-lasting cells in the body are the brain cells. And most prion disease are problems for the neurons, the brain cells of the body. Then this particular protein does something that most proteins certainly can't do. It then induces the animal to produce, or the human, to produce multiple copies of that same protein. And that's all it does. So it's not as if it produces dangerous enzymes, it doesn't produce toxins or anything like that. All it does is get into the brain and then cause the brain cells to multiply the protein. Lots and lots of copies of the protein. Now, does that sound bad? Well, if that clogs up the neuron, the brain cell, and the brain cell can't work because it's clogged up with all this protein stuff that it's produced, then obviously it's not going to work very well, and therefore the nervous system's not going to be working well at all. Okay, so very interesting, strange sort of pathogen, and luckily there's not too many prion diseases. Typically with prion diseases, they have very long incubation period. If you think about what they have to do, in order to cause disease, they have to get into the brain cells and or nervous cells, and they then have to multiply and multiply. That takes a long time. So even before there's any signs, there's usually a long incubation period. Now, how long is long? Well, okay, if we're talking about incubation periods of some bacteria or whatever, we're typically talking about a couple of days. Virus, a couple of days. In this case, we're talking about months, if not years, if not decades. So very long incubation periods and generally slow development. But the trouble is that might be slow, but eventually it can end up causing quite severe problems. Okay, so in the past, we did know about certain prion diseases. There was a prion disease that was seen in humans, and this was actually investigated in the 1970s and this was brilliant work done by an epidemiologist, human epidemiologist, who went up into the highlands of New Guinea and investigated a strange disease called Kuru. In the case of Kuru, which is also known as Creutzfeldt-Jakob's disease, it's a really strange thing because it starts out as people slowly but surely degenerating, and they start to get shivers and shakes, and then they lose control of more and more functions of their body, and eventually they can't get around, they can't look after themselves, and they eventually die. Now, it often takes a few years to do that, but it sort of slowly comes on and takes over the body, takes over the brain, and these people will eventually all die. And Kuru had been around for quite some time, only in the upper areas of the New Guinea highlands, very localised around a particular area, and it was quite a puzzle as to what was going on there. The people affected, the villagers affected, were quite convinced it had to be some sort of magic or sorcery or whatever, so they were looking for someone to blame for that, because they didn't really have much of a better understanding of it, and initially we didn't have much of a better understanding of it at all. But some really brilliant work actually uncovered the fact that it was a prion, and the brains actually showed that there was this protein. But the trouble is, how did this protein go from individual to individual? And it turned out, this is the brilliant epidemiological work, actually showed that there was a very unique custom that these villagers had. And this was where the women, and this was seen much more commonly in the women, as a sign of respect and admiration of their dead relatives, would actually eat the brains of their dead relatives. And so this was actually the cause of the prion going from the brains of the people affected into the brains of the people that consumed it. Okay, luckily, Kuru has almost disappeared. Unfortunately, because of such a long incubation period and slow development, there's still a possibility there might be still a couple of cases still to come. But basically, it's disappeared, and it's disappeared for one simple reason: that practice is no longer done. And so, because there's no consumption of that, then basically this has died out of the New Guinea highlands. Okay, so that's an interesting story. The other prion I could tell you about is that for a long, long time we've known about a prion disease in sheep. It seems to be mainly only in sheep in the UK, but in sheep there's a disease, it's called circling disease because it affects the brains of these sheep and they end up sort of just wandering around in circles aimlessly. Eventually it can get worse and the animals are generally put down. And this is a prion disease that we've known about for a long time. It doesn't seem to have been an effect for any other animals, so it was more of a strange, unusual disease that we might have been interested in, but not really anything that seemed to be an immediate threat. And then, what happened in the 1980s is 2 outbreaks of brand new prion diseases occurred. And first off, there were cattle that were found to all of a sudden develop some really dreadful central nervous system signs. This is a cow that's getting all staggery and falling over and obviously not coping with things pretty well. And so they get the shivers and shakes and stagger and fall over. Okay, so that sounds pretty bad. The trouble was, this is an emergent disease, never seen in cattle before. So, okay, some investigation was done. Looking at the brains indicated that there was protein in the brains. They looked at this protein in the brains and they found that it seemed to be identical to the protein that was found in the protein for these sheep with scrapie. So what had gone on here? Well, some investigation had turned out. It turned out that what had been the cause of this, the initial cause of this, was feeding sheep brains and meat to cattle. Now you might say, but how can that be? Because cattle are actually herbivores, aren't they? They don't eat meat. Well, in the formulation of animal diets, we need to get a certain level of protein. So what happens if we try to formulate a diet and we want to get up higher protein? Now, to achieve higher protein, for example, for dairy cows, they need high protein diets. An easy way to actually do that is to put meat into the diet. So for our diets, if you're not getting enough protein, the easiest way to increase your protein is to eat meat. Okay, for the vegetarians and the vegans, yes, there's other ways we can do it, but it's not quite so simple. So, in spite of the fact that some of you might feel uneasy about this, for a long time, it was seen as an okay process to actually increase protein, because protein's protein when it's broken down to amino acids, by putting meat products into the diets of cattle. Now, that's not feeding bits of meat to the cattle, it's all processed and pelleted and whatever. However, you might think, well, isn't that a danger? What about salmonella and campylobacter and all sorts of other things? Well, that should have been the process that should have prevented what I'm about to mention. If there'd been proper processing of that meat product, the brains and the meat and the nerves of the sheep, these are sheep that have sort of died or whatever, of all sorts of things, but maybe they have the scrapie organism. If they'd been properly processed, which is basically a cooking process, before it had been incorporated into the diet, we wouldn't have had the problem. It turned out that there were some shortcuts, there were some people, not checking the system properly, and it was found that in the processing of these sheep for the diets for the cattle, this hadn't been done as well as it should have been. And what this meant is that for the first time ever, there was a transfer from from sheep with scrapie to cattle. And then cattle had their own version of the prion disease. Okay, so that's pretty bad for the cattle. And basically it was a matter of doing a couple of things. One is to identify the cows that have had this, and also to have a universal ban on the feeding of animal products to cattle. and sheep for that matter as well. Sounds a pretty good idea. Now, okay, that should have been the complete end of it. Unfortunately, there's been continued outbreaks of bovine spongiform encephalitis, although that's quietened down over the recent years. But even about 5 years ago, there was a bit of an outbreak, and every time there's been an outbreak, when people investigate it, someone stuffed up. Someone hasn't done the right thing, and they're fed some sort of bone meal, for example. Bone meal has lots of calcium, so if you want calcium in the diet, bone meal seems to be a really good way to increase the calcium level. And these things have been banned universally around the world, and when people aren't compliant, this is when we do get further cases of this in cattle. However, simultaneously in Europe, there was another outbreak of another prion disease, and this is in humans. And this is where people started to come up with the signs that I was talking about of the New Guinea Highlanders, the Kuru signs. And so people were going to doctors and being identified as having Creutzfeldt-Jakob disease. And presumably in the process they were being asked, have you been to the New Guinea Highlands? No, you haven't been, okay. Have you been eating the brains of anyone lately? No, you haven't been doing that. I'd imagine they have to ask those questions, but they're sort of pretty confronting questions, because these are people that are getting very, very sick and getting all sorts of neurological problems, and they are definitely going to die. There's no cure for this. And so the question was, where has this come from? Well, wait a minute, this was happening simultaneously that it was getting into the cattle. So when it was a prion disease in sheep, we had no cases of it occurring in humans. People have been eating sheep meat forever. No problems there. But when it had transferred into cattle, there'd been some change to the protein to allow it then to jump from cattle into humans and cause a really nasty disease in humans. So in Europe in the 1980s, there were a few hundred people that became contaminated by eating meat, in this case mainly cattle meat, beef, various forms or whatever, and anyone who was in Europe and eating meat in the 1980s potentially could have been at risk of this particular disease. We're still getting the new cases from that 1980s outbreak because of the long incubation period or whatever. So I would hope that because we now are very meticulous, hopefully very meticulous, about what we do with the feeding of cattle, that we're not going to see any more outbreaks of this. But I can't guarantee that that's not going to be the case. But even if we don't see any more cases, I think this is a really good lesson to say we do need to be very, very careful about how we feed our meat-producing animals and the processes that are involved in that. Unfortunately, I think this variation of Creutzfeldt-Jakob disease that I've just talked about, which is the human disease, is a real warning. Dreadful, dreadful death. No avoiding that death, and it's something that we created ourselves in the processes that we produced. Okay, so now let's move on to diseases and risks from animals. And I touched on this last time, but now we're going to give you some examples of this. So these are diseases that we can get from contact with animals. So these are zoonoses. Okay, so for the people that are producing animals for human consumption, potentially they are at risk of these diseases. So if we're in contact with these animals, we might be in contact with that. For those that aren't in contact with those animals, the risks may be less, but not necessarily zero, as we'll mention. Okay, so one of those is leptospirosis. In this particular case, this used to be a major problem for dairy farmers and also their families. So this is actually an organism. There's a number of different species of Leptospira, but this can be seen in a wide variety of animals: cattle, dogs, pigs, sheep, and humans. So in animals, you get fever, anemia, jaundice, and late abortions. and a fall in milk production. So in dairy cows, which is the main area that I'm going to be talking about, although it does occur in pig farms as well, and can occur with those other animals as well, we can also pick up that infection. And in humans, you can get the, well, it depends on the person as to what you get. For some people, they get a bit of a cold. It's sort of like having the flu, a bit of a headache and a bit of a fever, and then they get over it. So for a lot of people, they actually would get leptospirosis and not realise that they've actually had leptospirosis. They just thought, oh, I had a bit of a cold for a while, I had a flu for a while, and for a couple of days, and then I got over it. And for the greater percentage of people, that's all they'd ever have. So that doesn't seem to be much of a problem. However, for a proportion of people that get infected, something like about 10 to 15% of the people that get infected then have much worse. And this can include things like conjunctivitis, vomiting, abdominal pain, and then a proportion of those go on to have chronic signs. And this is where things get really nasty, because they have chronic debilitation. You get up in the morning and you just don't feel like you can do anything. Some of you might say, oh, coming up to exam time, I feel like that. But you wake up in the morning, you've got no energy. If you try and do things, you very quickly become exhausted. You've got aches and pains in your joints, and you just don't feel like doing things. You're greatly debilitated, and unfortunately that can go for days and days, then it sort of disappears for a while, and then it comes back again, and there's days like that. So you don't seem to be able to recover from that. So how are these people getting infected? It's not just the dairy farmer, and it's often people that might be close by to where the cows are actually being milked. And so this includes the wider variety of people in there, including the family. And this can actually occur from the urine. Now, in the dairy cows, quite often it infects the kidneys, and so this means that the organism is shed through the urine. And so in a dairy shed, this is a sort of a typical dairy shed where here's the cows there, and you can imagine, here's the cow being milked, and she feels like she has to urinate, so she lifts up the tail and out comes the urine, and there's usually a bit of a cloud of fine particles of urine there as well. Now, if there's any cuts or scratches that you have on your skin, and that makes contact with those fine little droplets, then this can mean that you can get the infection there. Again, maybe I should try and get some more recent figures, but 249 cases in Australia. Previous to that, the level was much greater than that. And these are the reported ones. And so this has been an issue that has been a major problem for dairy farmers and their families. Nowadays, it's becoming less of a problem because we're now more aware of it. The dairy farmers are more aware of this disease. The doctors in rural areas are more aware of this, and they're very quick to then pick up that it might be actually leptospirosis. But the big change that's taken place is vaccination. And so, although you might say, well, what's the benefit for the cows to be vaccinated? Well, I'd say there might be an improvement in milk production. In a lot of cases, it may not necessarily be of great advantage to the milk production, it may not be a great advantage to the cows, but it might be a fantastic prevention of leptospirosis in the dairy people. And so, therefore, more and more herds of dairy cows are being vaccinated to protect the dairy farmer and their family and other people who might be in contact with that. Okay, another one that can be really nasty, and not necessarily only the people who are associated with animals, is Q fever, Coxiella burnetii, and this is a little protozoa. And it's found in sheep, goats, cattle, and a lot of wild animals as well. It's not seen in pigs, for example. And it can be spread in the wild animals by kangaroo tick. Now, in the case of these animals, this is a little protozoa that multiplies and gets into tissue. Some tissue more than others. And for a lot of these animals, there's not much to see. Now, if you had an infection of Q fever, you're probably going to feel not completely normal. But for a lot of these animals, there don't seem to be many problems once the initial infection's taken place. However, it can build up in really large amounts in placental tissue, so animals that are giving birth in particular are at risk of building up large amounts, and excreta of various types. So, this means we can be at risk, humans could be at risk, with contamination from straw, from wool, from hides, and it could also be contaminated from contact with animal products, including milk and the like. Now again, some people will be infected and it might seem like a bit of a flu or something like that, and they get over it and that's the end of it. But for some it can be particularly nasty. Muscle pains, headaches, high fever, relapses of endocarditis. So this is infection in the heart. So that's sounding pretty nasty. And again, some people may have recurring bouts of this for a long, long time. So therefore, this is something we certainly want to avoid. Now, okay, over 355 cases in Australia, that hasn't changed too much. And so we're a lot more aware of the fact that there are some risks, but we are at risk of that. Now, one of the main ways we can prevent this is vaccination. In this case, vaccination of the people. So if you are going to have any contact with sheep, goats, cattle or wild animals, anyone in contact with those animals on a regular basis? Okay, if you are, or if you're going to be in contact with those animals as part of your university studies, our faculty makes it a prerequisite that you are vaccinated against Q fever. And so that's the best prevention of this potentially really nasty disease. Some of us, for example, I know I've been in contact with Q fever. I've got antibodies in my blood, but I don't recall ever being infected with them. I presume I must have thought I had a bit of a cold or something like that, or a headache, and that's all I got. But luckily, I didn't have severe problems. But I've had it in the past. So, in order to prevent people taking that risk, vaccination becomes a really important thing. More recently, there's been some really big outbreaks of Q fever in localised areas, and one of those areas was in an area where they had goats dairy goats for producing dairy milk and dairy cheese. Now that's become much more popular over just recent years. There's been a lot of consumer interest in other milks such as dairy goat milk and dairy goat cheese. And unfortunately in the case of goats, potentially they can build up, if there's lots and lots of goats that are giving birth, they can build up large amounts of the organism. And this organism can also spread away from the farm into surrounding areas. Now, in the most recent case in Australia, which was the year before last, there were quite a large number of people not in the farm. There's a very large farm out of Geelong that has these dairy goats. But actually the people on the farm weren't the ones that had greatest risk. They were actually people away from there. For example, people working in an office alongside that area. In an outbreak in Holland a number of years ago, in the Netherlands a number of years ago, there was a whole village close to where there was in fact a lot of dairy goats, and that village had a major outbreak of Q fever, including in people who had no contact at all with the goats. So potentially this is something that can affect a number of other people. Okay, on to tetanus. And in the case of tetanus, we've got an organism that, well, this is an organism that's actually found in the soil. So it's found in the soil. How it gets in the soil we'll mention in a second. Now, this is a disease that's not that uncommon in sheep, cattle, and horses. And in fact, in the case of sheep, it's one of 5 types of clostridial infections. So the disease is due to a bacteria called Clostridium tetani, and these are nasty bacteria that produce a number of toxins. Depending on which Clostridium it is, we can get various signs and whatever. So we can prevent it in animals by vaccinating against it, which I'll talk about. But in this particular case, the problem isn't really the organism directly. It sort of is, but it's actually a toxin produced by the organism. So the most common way that Clostridium causes a problem, Clostridium tetani causes tetanus, is the organism gets access to an area that has the right conditions. Now this is an anaerobic organism. It cannot stand oxygen. So if there's oxygen around, it can't multiply. Well, that's okay out in the soil. You might say there's lots of oxygen in the atmosphere. Well, in the soil, it's in a spore form. So it's got a very thick wall that protects it for many years. So it can sit in the soil there, but it's waiting for the right conditions, or the wrong conditions. And those conditions are basically an area where there's going to be nutrients for the bacteria to multiply, but no oxygen. So soil, when's it going to have those opportunities? Well, often a wound. And an animal or a human has a wound, and that wound, especially if it's a deep wound, and for some time there's going to be an area inside that wound that's not going to have blood supply. And because there's no blood supply in that deep wound, there's not going to be much oxygen getting into that area. And that's the ideal circumstance for this multiplication to take place of the Clostridium tetani organism. What then happens over only a few days is the microorganism multiplies and it produces a toxin. So the tetanus toxin is produced. And then, typically what's going to happen is the blood supply is resumed to that area and the organism disappears. So when the problem occurs is there's no bacteria. The bacteria has already disappeared. But the toxin has already been taken into the body, absorbed into the body. It's then absorbed into the nerves, and it travels up the nerves towards the brain. Now, it typically doesn't get to the brain, but as it's travelling up towards the spinal cord, it actually causes progressive ascending paralysis. So ascending paralysis meaning it starts off at the legs and becomes stiff paralysis of more and more. And we can see a dog with the effects and a lamb with the effects, and this causes a nasty paralysis because of activation of muscle that's uncontrolled, activation of muscle. Now, the thing is, this is a disease that can also affect people. In fact, a common term for this disease is lockjaw, because eventually it can cause the muscles that you use for chewing to just lock up as well. Now, here in Australia, luckily, we don't see many cases of tetanus in people. And there's one good reason for that, and that's because we vaccinate. Most of us are vaccinated for tetanus. And the good news about the vaccination is you don't need a lot of vaccine to actually create a good protection against tetanus toxoid, the toxin. And so therefore we don't see it here. However, this is a major killer in developing and underdeveloped countries. It's still one of the big major killers of people worldwide. So we do have the organism all over the place. And in fact, if you have places with animal manure, especially horse manure, it actually multiplies in the manure before it comes in contact with the oxygen. And so anywhere there's been sort of animal manure used for fertilising the soil, we're probably likely to have the organism there, the spore there, waiting to cause problems. So there's no getting rid of it. There's no way that we can envisage to eliminate the tetanus toxoid, the tetanus organism. We've just got to accept that it's there. The spores are already in the soil. They're going to be in the soil. So what we've got to do is prevent it from the animals getting infected by using the vaccine, and also prevent us from getting the disease by vaccinating us as well. Worldwide, around about 0.16 per million people die each year of tetanus. Now, okay, that seems like a small proportion, but that ends up being a lot of people. Okay, let's have a quick break, and we'll say 3 minutes, and then I'll continue on. Okay, will we make another start? You might not say that's 3 minutes. I think that's 3 minutes. So, just a bit of an explanation of what I'm doing. I'm giving you a lot of examples of diseases. I'm not trying to give you a comprehensive list of all the diseases that are zoonoses, all the diseases that can cause food poisoning, but rather what I'm trying to use them as is examples of certain principles or whatever. So when you're looking at all that detail, detail can be useful in understanding something, but I think the important thing is to think about these issues that I'm bringing up as I'm talking about this. And one of the issues is when we look at this next disease, which is schistosomiasis or biliaria disease. This is a parasitic disease that we don't have here in Australia. However, I've put this up because this is a major issue for human health and animal health in a large number of countries, especially in tropical areas. So this is a parasitic disease that is one of the big killers, one of the big diseases that does have major impact worldwide on our population as well as on the cattle population. And this is a trematode. Now this trematode has an interesting life cycle. It basically lives in the intestines of the people, and then the organism lays a small egg that then gets into a snail that's in waterways. And so it lives in the waterways for some time. It then comes out of the snails, and then it forms another type of larvae that is near the waterways where people might be there, and then if you're swimming or you're going down to wash or you're doing whatever with that water, you can then take that organism, and that organism can then be taken into the body. It can actually penetrate through the skin and can cause some nasty problems there. Now, in the case of cattle, they can be the major host of these. And it's not particularly good for cattle. It causes chronic wasting. But if instead of infecting cattle, it infects people, this can be pretty nasty with abdominal pain, coughing, diarrhea, fever, fatigue, hepatosplenomegaly, which means you end up with a big swollen liver and a big swollen spleen, and papular dermatitis, so little marks on the skin. So the skin things might look like they're the most obvious thing, but in fact the other signs are much, much worse. So this is a major cause, has a major impact on health and welfare of people in a large number of tropical countries where this is in fact endemic. Okay, so this is something where if we do have cattle there and the organism is there, this is going to put humans at great risk. Now, you can try and avoid it. If you are very careful about contact with the water, you can minimise that, but it's very hard to completely eradicate from those particular areas. In parts of Africa, the only way to eradicate it has been to actually get rid of cattle completely from those areas. This then causes some major social issues, because then you might have people that own these cattle and they're a major source of their income, they're a major source of their pride, and to just say, well, get rid of the cattle doesn't necessarily mean that that's going to be an easy choice to make. So here's an example of a very widespread disease that has nasty effects on humans, but is due to our close association with other animals such as cattle. Okay, the next disease, not so nasty, but nevertheless it's a zoonotic disease that I wanted to mention, and this is seen from cattle, some sheep. Now, it's called scabby mouth, and this sheep here, you can see there's got that scabbiness there, and this is basically because it's got little pustules that form, little little blistery things that then break open and they form little scabby little areas. Now, they're often seen around the face, and that's because this is caused by a virus that gets in little cuts and places like that. So areas where there's not much wool are more likely to have it. But it can be found in other areas as well. Up the top we can see that there's some little vesicles, little blisters that are found on the wool there, and they can be found around the feet as well. So they can be found in a number of those areas. Now it turns out a proportion of our farms with sheep in Australia have it, and a proportion don't have it. And for the sheep it's not too great a problem. It usually resolves about 3 weeks. That's not looking particularly nice. It's not particularly good for the sheep to have it, but after 3 weeks they get over it. However, what's the risk of this? It's also a zoonosis. In the case of people, you can end up with nasty rashes from that. Now, it's not a great risk to the human life, but it certainly is a zoonosis. It certainly can spread from sheep onto people, and you can end up with a nasty reaction. Now, there is a vaccine for it, and so for the places that have it, they can vaccinate for it, and then you can make sure that you don't have that disease. Vaccination is basically giving the virus to it, but what we do is scratch a little area of skin away from the feet, away from the nose, that doesn't really cause much of a problem for the sheep, and the sheep get over the infection without it causing any problems, because it's only a little scratch somewhere on the skin. Now, if you don't have the infection, that's okay. But what happens if you've got the infection? Okay, if you vaccinate, then that shouldn't be a problem. But what happens if we take sheep that might be coming from farms that have it and sheep that are coming from farms that don't have it? Well, the worst thing we could do is mix them all together and keep them mixed together for about 3 or 4 weeks while they're in close proximity. So they're going to be nose to nose and very close proximity for about 3 weeks. And 3 to 6 weeks. And we actually do that with our sheep. And we do that with a very controversial process called live exports. So more recently, who's been hearing about live exports in the press? There's some major issues about welfare of these animals, and part of the concern about welfare of these animals in the past has been scabby mouth. Now, in this particular outbreak, this particular episode, scabby mouth hasn't been part of the problem. But in fact, in the past, regularly, there has been issues about live export, and scabby mouth has certainly been part of it. Now, you might say, this is not a nasty disease, so why should we worry about it? But let's imagine that you're a customer from the Middle East, and maybe you've bought these sheep that have come from Australia. Now, here in Australia, we like to claim that we're clean and everything's nice here in Australia. We're in the sunshine, whatever. But our animals, they don't have nasty diseases. Well, this is not a particularly nice disease. We might say it's not that bad, but it's a disease that they may not have in other countries, for example. So we put these sheep on the boats and we send them over and we say, surely you want our nice, healthy, free from disease sheep. So after about 3 to 6 weeks, this is the ideal circumstance for the sheep to pass the virus around these sheep that haven't already had the virus, and to then have the signs. And so, unfortunately, a number of times, the boats have got to the Middle East and they've been inspected, and there's been a large percentage of them that are showing the signs of scabby mouth. That hasn't gone down very well at all. And in fact, what then happens is a major welfare issue. They get rejected from that country. And so you've got a sheep in a hot environment, and it's been rejected. It can't unload those sheep at that country. And we've had this situation a number of times where these sheep have got no other country to go to. And so some pretty fast negotiation has to be done to find a country where these sheep can get off. If they stay on the boat, they're going to die. It's too hot, it's been a long journey, they need to get off the boat. But they can't get off the boat if a country won't accept them because of this disease. It is a potential zoonosis, and so unfortunately this has put the live export industry at great risk in the past, and I'm going to make the comment that I think it's a sign that they really haven't perhaps really thought through their systems, and they haven't taken it seriously. That this is just one of the examples of the fact that their systems haven't coped with this very well. This more recent one seems to be more about dying sheep and the welfare issues per se, rather than about scabby mouth. But I think we need to do much, much better with live exporting of sheep than in the past. It shouldn't happen. Basically, if you've got sheep going for live export, they should be vaccinated. Even if they've come from a place that hasn't had it in the past, they're supposed to be vaccinated. If they've been vaccinated, then there shouldn't be any spread of this disease in the past. I think it's an indictment of a system that here's an easy process to prevent the problem, and what we've seen is it hasn't been prevented. So therefore, I think you've got to question how well this system has worked in the past. Okay, so yeah, there's ways we can actually do it. In humans, you get little scabby, scratchy, horrible things. They clear up. It's not going to kill you, but it's still something that I think we shouldn't be spreading around. Okay, this next one is also one that we have in our grasp the ability to prevent, and this is a much nastier one. This is Hydatid disease caused by another parasite called Echinococcus granulosum, and this is a little cestode. It's a little tapeworm, but this little tapeworm is, I'm saying little tapeworm because it's a tiny little tapeworm. So you might have heard about big long tapeworms. This is only a little tiny tapeworm, and it's only found in dogs. The actual tapeworm is only found in dogs. So dogs can have this particular tapeworm, and the tapeworm has little segments, and these segments drop off and they spread eggs. Now the thing is with this cestode tapeworm cycle, it needs to find a secondary host. It needs to go through a development stage, and it needs to go through another animal. So not the dog. So the dog has the adult worm. Where has the dog spread the eggs? Well, you know, dogs sort of defecate all over the place, so potentially the eggs could be anywhere. For example, you could actually have it that you're out in the garden and you're doing some gardening or something like that, and you make some contact with something where the eggs might have been. Now, one thing that you should do if you've been outside is, before you have your meal, wash your hands. Very good idea. And one of the things that hopefully you do is wash the eggs of the Hydatid worm off if you came in contact with them. Unfortunately, that doesn't always happen. Now, the thing is, what it needs is this secondary host, and the main secondary host for this parasite is the sheep. So the sheep ingest the eggs. They then form cysts inside the internal organs of the sheep, including in the liver, in the lungs, and places like that. And so it basically will develop a cyst that will grow and grow and grow. Now, for the life cycle of the worm, what is happening there is it's waiting. So the parasite is waiting and waiting and waiting. What's it waiting for? It's waiting to be consumed by a dog. So if the dog consumes the internal organs of the sheep, all the visceral organs of the sheep, if the dog eats the liver or the lungs or whatever, it can then complete the life cycle, and so then it then forms the adult form, and that's it. It doesn't really cause any problems for the dog. So the dog doesn't really suffer too much from it. In the case of the sheep, this is fairly slowly growing, and so most sheep are going to be killed before it becomes a major problem. Now, if it grows and grows and grows, it'll start to put pressure on all the organs around wherever it's growing. So it sounds like it's sort of something that maybe we don't need to worry about. Well, we do need to be worried about it, because there's around about a dozen or more new cases of this in Victoria per year in humans. And this is where, instead of the sheep cycle occurring, we've got dog humans. Now, it's probably not going to be, when our internal organs probably aren't going to be eaten by the dog, but that doesn't stop the parasite thinking, well, I have to form this cyst inside of the person that is then infected. And so this is you know, a dozen to 20 cases per year that we're seeing here in Victoria. Other states, there's also cases as well. So what actually happens? Well, typically people have had it for some time. They haven't been aware that they've had it for some time, but they seem to be putting on a lot of weight. And quite often, by the time it actually gets diagnosed, when it's actually starting to cause problems by its size and starting to push against other organs, quite often these can be a number of kilograms, a number of litres of fluid in the cysts, up to sort of 10, even 15 litres of fluid of the cyst. Now, if we get to the stage where they're fairly large cysts, you need to remove those cysts, but it's not going to be easy to remove those cysts because they're big cysts. And up the top we have an operation that's being performed, and this needs to be done to these people who get the disease, and this is a nasty operation. And unfortunately, it's often not the only operation to remove the cysts. There's often a number of operations, pretty big operations, to remove cysts that large from the abdomen of the people in order to be able to eradicate this from that particular person. So for the people that are affected, not huge numbers, but nevertheless, for the people that are affected, this has a major, major effect on their health. Now, the sad part of this is it's very preventable. And all we need to do is two things. One is we need to make sure that the dogs are regularly wormed so that they don't have the parasite. That should be fairly straightforward. But even more straightforward should be we should make sure that dogs do not have access to offal from sheep, uncooked offal from sheep. Now, if it's cooked or if it's processed, that kills the organism. There's no worries about that. But quite often on a farm, there might be some sheep, and the farmer kills one of the sheep for meat for the family, and then no one wants to eat all the offal, so what do you do about that? And it's very tempting to give that to the dogs. We've got to really prevent that from happening because this is continuing the life cycle of this particular nasty disease. So doesn't seem to be a problem for the sheep, doesn't seem to be a problem for the dogs, but it is a major, major problem for the people that get infected. It is possible to eradicate it. Tasmania did this way back in the 1970s. And without a lot of technology or without a lot of things, basically by one thing, trying to make it so that the farmers did not feed offal to the dogs, and also worming all the dogs simultaneously, basically eradicated it from Tasmania. We could have done the same thing here in mainland Australia. We just haven't taken the effort to do that. Okay, so now I want to move on to some future threats of animal diseases. So I've talked about the diseases we've already got. But what about future threats, things that might be around the corner? So I'm doing some predictions about things, but I'm also using these as examples of diseases that I don't know about in the future. Now, one of them is actually a disease that I know we will be seeing in the future here in Australia, and this is anthrax. Now, this is a nasty disease. Again, the organism, Bacillus anthracis, isn't really the problem. It's actually the toxin that's produced by this organism. And this organism sits in the soil as a spore, so in some ways it's similar to the tetanus situation. But it's sitting there and it's waiting. Now, the unique thing about the spore of this organism is we don't know how long it can last, but we know it can last at least 100 years. And there's been cases of anthrax in cattle, in animals in Australia in the past, basically in a big band inland eastern Australia. And from that we know that this anthrax belt has soil that contains the spores. So right now I don't know of any cases of anthrax, but what I can say is that there's likely to be some future cases of anthrax because I know the spores are out there. And it just requires the wrong circumstances to take place where the animal ingests the spores multiply, and then when they multiply, very quickly things can start to happen. If they are ingested and they multiply, very quickly they multiply and they kill the animal quite quickly. Here's an animal that maybe died within, say, 6 hours of first ingesting the bacteria. So the toxin is very, very deadly. Unfortunately, the organism is multiplied throughout the whole body of that cow, and then it can be the source of outbreaks elsewhere. It's an organism that once it gets the right conditions to multiply, it multiplies very quickly and very, very easily. And it's a zoonosis. Here's a person with a scratch. This person actually was working in an abattoir, and an animal that had anthrax came to the abattoir, and they made some contact with the blood of that animal, and they maybe had a scratch there, and they just touched that, and that probably looks pretty nasty. But the bad thing is, this person, if they don't get treatment, will die probably in about 6 hours. So, you know, you might think, oh, that doesn't look too bad. Oh, it'd be nasty to have. But the trouble is, this is indicating this person is building up levels of the toxin, and if without treatment, they will die very, very quickly. So this is a very, very deadly disease. Okay, so we need to be on the outlook of this, and there will be future cases in Australia, and it's very important that they are picked up as early as possible so that they don't spread to other animals and they don't spread to humans as well. But there's another reason we need to be concerned about this, and this is because this has been an organism that's been picked up as a probable organism for future bioterrorism. So terrorism is, okay, well, I might have some sort of grievance about something and I can set off a bomb. Well, that's one way I could cause mayhem. But another way, and this could be potentially a very nasty thing to do, is I can multiply the anthrax organism. It's very easy to grow in a laboratory. You just need to get access to the anthrax. Well, I said it's out there in the soil. So if you know what you're looking for, you could easily grow the anthrax organism. And then you've got a choice. You can either send the anthrax as a powder in the mail, in letters to various people, and they open up the letters and go, oh, there's just a white powder. So what? And if they inhale the white powder, they'll probably die. And this has happened in the past. So there's been people in the US, for example, that have created the white powder, sent it in envelopes. In most cases, luckily, it's been picked up that something's going on before people have actually been in contact. But this is potentially a very nasty form of bioterrorism. Or the other thing that they could do is to actually take the organism, inject a few animals and allow the spread of the disease in various parts of the country. Again, that would cause major mayhem across the country. There's a number of other diseases that could be used in this particular way. So I'd like to think this won't happen, but the evidence is that this is something we do need to take very seriously, that bioterrorism, the use of these organisms, these zoonotic organisms, could potentially be something that terrorist organisations use in the future. There's certainly been plans, there's certainly been attempts. There haven't been any big successful attempts so far, but maybe that's a matter of time. Okay, changing tact a little bit. Here's a disease that's actually quite rife in Australia. So why am I including it in this particular case? Well, let me talk about it. This is called Johne's disease. It's caused by Mycobacterium Johneii, Mycobacterium pseudotuberculosis. Its old name used to be Johneii. And it's seen in a number of different animals. It's seen in cattle. And typically what we get is not in young animals, but in older animals, they start to not do very well. They start to look skinny, and they end up with a really bad diarrhea. And this is a really constant diarrhea. Now, vets love to use, I don't know why, but us vets seem to love food analogies. So you might not agree that it's a good thing to use food analogies, but we think it's a great idea to use food analogies. And if you can think of a nice batch of pea soup, well, that's what the diarrhea is like. I think it's a rather good description of it, but pea soup diarrhea is typically what these cows have. So here up the top, we've got a very skinny cow lifting up its tail, and it's now gushing out this pea soup diarrhea. And unfortunately, this isn't just a temporary thing. This is going to continue day after day, week after week, month after month, year after year, until eventually the cow gets so skinny that we'll have to do something and probably kill the animal, euthanize the animal. The thing is that this occurs very slowly. So this is like a disease outbreak in slow motion. It takes a long time for the first signs to occur. It takes a long time for the disease to progress, but it progresses. And then spreading from animal to animal, it's again quite slow. So if we first saw it on a farm, it'll take quite a number of years for it to spread through the farm. From farm to farm, it might take a number of decades to spread from the farm to the farm. At present, we're in the middle of an outbreak, a big epidemic that's spreading across Australia. It's already spread to quite a number of our dairy farms, and it's now spreading to a large number of our beef farms. So here in Australia, like a lot of countries in the world with cattle, we have an epidemic that's slowly spreading through our animals. And when things happen very slowly, sometimes us humans aren't good at appreciating the danger. And so we're concerned about it, but maybe we should be more concerned about it. Okay, so nasty for cattle, but you might say, well, yeah, okay, but it doesn't sound that bad. They can still be productive animals for quite a while. So, yeah, maybe it's not a great thing, but really is it there's something that we need to really panic about? Okay, what about with sheep? Well, in the case of sheep, it's slightly different. What actually happens is we get chronic inflammation of the intestines. Now, that explains the signs that we get in the cattle. In the case of sheep, they don't actually get the diarrhoea, but they do get the wasting away. And if we take a look at their intestines, we see instead of a normal intestines, it's all swollen up, and it's all thick, and it's all hard. And that's because of inflammation that's taken place in the gut wall. Again, it does, for a lot of farmers, even if it's in their flock, they don't see it as a major problem because only a small proportion of their sheep seem to be affected by it, and it doesn't seem to be a major threat to them. I'm about to say why they need to take it much, much more seriously. Okay, so because it's slow, I think that's part of the reason why perhaps we haven't been so focused on it. Now, we can take measures against it, but we've got to be very diligent over a long, long, long time. So hygiene, preventing it, for example, the diarrhoea spreading to younger cows is an important thing that we need to do. And eradication is possible, but it's difficult. We need to make a really concerted effort to do that. There's been pushes to try and to look at eradication in cattle and in sheep, and we haven't really made major inroads into it. And there's one major reason why we perhaps should push it a little bit harder than what we have. And that's because there's an unproven link with a human disease. Now, this, I think, changes things dramatically. There's a nasty disease in humans called Crohn's disease. And this is a disease where there's wastage, people just slowly but surely lose weight and lose weight and lose weight, become weaker and weaker and weaker. And they also get chronic diarrhoea. And if you look at their intestines, they end up with thickened, inflamed intestines. It takes them a number of years to develop the disease, but it slowly develops and it doesn't get any better. And eventually they die of this disease. So I think you can probably already make this connection that, hey, that's sounding a little bit like, especially with cattle, that this might actually sound a little bit similar to what's going on in cattle. Now, at this present stage, we do not know the actual causes of Johne's disease. However, there's been a couple of papers that have made the suggestion there could be a link to Mycobacterium pseudotuberculosis. Now, the trouble is, at this present stage, there's more research that needs to be done on us understanding what's going on with Crohn's disease. But at this present stage, there is a potential threat that there is a possible link between Johne's disease and Crohn's disease. Now, we can take two views about this. One, we can say, no, they haven't proven it yet. So let's keep doing what we're doing. There's no proven link. That's true. There's no proven link at this point between Johne's disease and Crohn's disease. So let's forget about it. Or we'll wait. We'll wait until someone says, oh yes, there is a definite link between Crohn's disease and Johne's disease. Oh, and then we'll do something about it. Well, remember this is such a slow disease, we won't be able to just suddenly turn it all around and get it to disappear. So if we want to control it, what do we need to do? We need to think about it, and we need to plan over decades in order to be able to try and eradicate it. I think maybe there's some really good reasons why we should eradicate it, beyond just the possible link to Crohn's disease. But what is worrying a large number of countries is that if there's a link with Crohn's disease, this can have dramatic effects on the countries that have this disease, including Australia. So if we ignore it, maybe things will be okay and no one will worry about it. But if things change, this could have a dramatic effect on our sheep and cattle populations here in Australia and the livelihoods of farmers in this particular area. So this is a potential threat. At this present stage, there's no definite scientific link, there's no definite threat here, but regardless, what I'm saying, this is an example of perhaps we need to be prepared to anticipate a possible threat. Okay, now we're moving on to another group of diseases, and these are these diseases I mentioned before, emergent diseases. And this is a good example of them. This is Nipah virus. Before 1999, we had no idea about this disease. And this is a disease caused by paramyxovirus. It's a virus, heniparvovirus, closely linked to another virus, which I won't talk too much about today, which is here in Australia called Hendra, but it's a horse and human disease. But this is a disease that has been found in large parts of Southeast Asia and Southern Asia. If you have a look at the sort of the blue part of the map, this is where Nipah virus is currently located. Now, this is an interesting story because this is a disease that just suddenly appeared. The first time it was actually noticed was actually in 1999 in Malaysia, in Peninsular Malaysia. And there was a particularly on-the-ball doctor who was in a part of Malaysia. And this was a sort of a bit of an outpost area, not near a major town or whatever. So it's really good that we've got good doctors in all sorts of different areas. Now, he was in an area that was fairly newly developed. This was an area where there was some tropical rainforest areas that had been taken over by farming. So the rainforest area had been cleared and the farming was now taking place. And so he's just going about his normal business, and then he noticed a few people get really sick and a few of them die. And he was very perplexed about this. It didn't seem to fit any of the diseases he knew of. Didn't fit. He did a number of tests, it didn't fit at all. However, he was smart enough to say, well, wait a minute, it can't just appear from nowhere. What's going on? And he happened to notice that some of his clients were pig farmers, and they were also talking about a sudden disease that had happened with the pigs. And then he checked, and no one seemed to know what was going on with the pigs. Why had the pigs died? They had a brand new disease, and the humans were dying of this brand new disease. He happened to have a brilliant idea, or along the way it happened that they decided that there might be a link to another disease, mysterious disease in Australia called Hendra virus. So fairly quickly they were able to do some testing, and they found out there was a brand new disease that had never been seen in pigs before, never seen in humans before, that was killing both humans and pigs. So where had this virus come from? Turns out this virus is a normal virus found in flying foxes. And so why had this happened? This flying foxes have had this virus for forever. I don't know, centuries, millennia, I don't know, for a long, long, long time. So how come this virus had been very nicely, compliantly only in flying foxes, and now it had spread to pigs, and from pigs it had spread to humans and was killing humans? Well, what had actually happened is that we had pushed into the reservoir areas of the flying foxes, into the habitat of the flying foxes. So by clearing those areas, the flying foxes had lost their habitat. Well, the flying foxes thought, well, this is pretty bad, but people were actually growing fruit trees and the like, and so they thought, oh, well, that's okay, we'll cohabitate with the people and with the pigs. And so this meant that there was an overlap of the habitat of the flying foxes and the people and the pigs. And this created the circumstances for a brand new disease to arrive. This is an example of a wide group of diseases such as SARS, coronavirus, bacillus, Meningel virus, Ebola virus probably fits into this, and Marburg virus as well. And these are bat viruses. And bats don't seem to be too worried about these viruses. But when the viruses go from bats to people, or bats to pigs, or bats to horses, or whatever, then potentially we can have brand new diseases. And some of these, such as SARS, you've probably heard of SARS. That was a major outbreak in humans, and it's come originally from flying foxes. Okay, so this is a sign for the future. We are continuing to push into habitats from other animals, such as flying foxes and other animals, and they have their own viruses. So how do we know that those viruses won't affect our domesticated animals or affect us? And the answer is we don't know. And so this is a risk that we do need to take very, very seriously. And this is a major cause of these emergent diseases. Question?
How is it transmitted from flying fox to pigs and humans?
That's a really good question. We don't know. There's all sorts of suggestions. Maybe it's sick foxes because there's flying foxes and pigs and whatever. Now, another example is there's another virus called Hendra virus, which spreads from horses and can spread from horses to humans, and there's a number of people who have died from this one. But the thing is, we have lots and lots of flying foxes, we have lots of horses in Australia, we have lots of people. So how come it's not happening all the time? But it happens sometimes. Now it happens in northern New South Wales and Queensland. We know that. Every year it happens. But here, just to worry you a little bit, here in Melbourne, you can see lots and lots of flying foxes. Anyone know where you'd see lots and lots of flying foxes? Very close to here. Go about, around about sundown, go down to the botanical gardens and have a look at this cloud that comes towards you. It's not a cloud, it's actually a whole lot of flying foxes that are just coming home to roost in the botanical gardens. Here in Melbourne, we have lots and lots of flying foxes, and CSIRO have done some testing. They have the actual virus that causes Hendra virus. So it doesn't. We don't actually have Nipah virus in this part, but we have the Hendra virus. So what we have is the flying foxes, and lots of them. So you can't just eradicate the flying foxes. They have the virus, but what we don't know quite yet is under what circumstances does the virus go then from the flying fox to the pigs in the case of Nipah virus, or the flying fox to the horse. In the case of Hendra virus. There's been lots of theories. Maybe it's stresses due to the flying foxes, maybe it's things like giving birth or whatever. There's been lots of theories. We still haven't really proven what circumstances will lead it. So all I can say is that we don't know, so therefore we don't know when it's next going to happen. I think this is really scary, and there's lots of these emergent diseases. Plus we've got another emergent disease called avian influenza, or more specifically, this is a type of influenza called H5N1. Now there's a number of different strains of influenza, and this is the latest scary one. There's a number of new ones that we're starting to get a bit more worried about. But the unique thing about influenza viruses is that they have a number of parts to their genome, and this means that they can play little games. Now if we have an influenza virus and it has a number of different sorts of genes on its little segments of the genome, and there's another virus, influenza virus, that also has its genome, and maybe it's got some different genes, what it can do is if it simultaneously infects the same cell, same animal at the same time, it can then reassort those genomes and it can produce new viruses, brand new mixes of those viruses. And this is what influenza does. Now this is great for the influenza virus because it can then recreate itself by mixing up new genes and whatever. And in fact, it needs to do this in very specific ways. It can basically do this in two types of animals. It can do it in pigs and it can do it in poultry and in birds. And there's one area where you have the right conditions for this to take place. So what we sort of don't want, but we have regardless, is an area where there's lots of people who might have influenza virus, and we also have pigs and or poultry, because the pigs and poultry can be infected by a large number of human influenza viruses, and they also have their own viruses as well. Now, at present, this means that pretty well each year there's a new virus, there's a new influenza virus. So you might say, oh, this is really boring. Every year I'm told I'm supposed to be vaccinated for influenza. Who's been vaccinated so far? But anyway. No? Oh, it should be fairly soon that you'll probably be offered to be vaccinated against influenza. So why every year? Because there's a new strain that's developed. And typically that's been incubated or created in Eastern Asia. Eastern Asia, lots of poultry, lots of pigs, lots of people. And so each year from that area, even though people start talking about, you know, Spanish flu or whatever, these viruses typically always originate from this particular area. Now, at present, we've got a virus strain of influenza that's not particularly nice, but it sort of causes some damage to humans, so it's a bit pathogenic to humans, and it spreads pretty easily. Now, some viruses we get spread extremely fast through our population. And some don't spread very fast, but they're actually pretty pathogenic. They're fairly deadly. Now, what we don't want to have happen is the roulette game plays, and we get a virus that's both deadly and spread very quickly. Now, that has happened in the past. After World War I, there was what was called Spanish flu. It didn't come from Spain, it actually originally came from Eastern Asia. But when it hit Europe, it killed more people in 1 year than died throughout the whole of World War I. So it came up just after World War I. It killed far more people than World War I killed people. Okay, could that happen again? The answer is yes, quite possibly. And so what we're trying to look out for is the next possible stage we could get to it. Now, why avian influenza H5N1 is of particular interest is it's almost there. It's one step away. In the case of avian influenza H5N1, it's particularly pathogenic. Most people that actually get infected by the virus die. So it's highly deadly. However, it turns out it's highly contagious between birds, but it's not very contagious between humans. What happens if this particular virus gets in the mix and gets mixed up with some other genes and we end up with another virus, and this virus then is highly contagious with humans? We have a serious, serious problem. And so this sounds really bad. This sounds like we really need to be on the guard. And we are on the guard for this. Okay, in the case of avian influenza, this occurred a number of years ago where we tracked it. For the first time, we tracked the development of this disease. So we knew it wasn't highly contagious in humans, but it was still pretty scary because it killed people, and it was spreading among the birds very quickly. Started in Eastern Asia, and we saw it migrate across. Now, it migrated across because there's migrating birds. And migrating birds spread it from there, Central Asia, to Europe. And day by day, it was being tracked into Europe. And so, okay, you could say that's the good news. We were able to track it, and luckily it was able to be contained in Europe. So as it came to Europe, it was contained, and you know, a great sigh of relief was made, because once it got to Europe and it was contained, it had nowhere else to go. So that was sort of the end of it, surely. Except this time something unique happened. These migrating birds, who are supposed to migrate from Eastern Asia to Europe, some of them took a left-hand turn. And some of these ended up in Africa. And this virus continues to multiply in Africa. So why did these birds make a left-hand turn? They'd never done it before. And the only explanation we have for this is climate change. So if you say, oh, climate change, oh, how nasty is climate change? Well, I reckon it's particularly nasty when it starts to change the distribution of diseases, when it starts to potentially create situations where we can have a continuation of potentially dangerous viruses that might then go the next step into really dangerous viruses. So I think we're talking about some pretty nasty things. Okay, so environmental change, there's lots of things that can affect... in fact, I'm going to zip over this because I think we're getting off the track a little bit. But environmental change, I think, has got major effects on animals and pasture and water supply and also vectors. So a number of the diseases that are spread spread by vectors. And one of the things that is changing quite quickly that we're noticing already is that the disease distribution is changing because the vectors that spread the disease are changing their locations as well. So I won't go through that, but you can see a number of viruses, Nipah virus and avian influenza and hantavirus. These ones are actually changing because the vectors are changing. So here's the extra little thing. I think we're at great risk because of the fact that not only are we getting emergent diseases, but where those emergent diseases are going to is changing because of climate change. So emergent disease plus climate change means really potentially nasty disease problems. I'm going to leave this next section to next week. I'll fit it into the next week thing. It's a bit of a change of topic. So let's leave it at that. Bit of a scary note, but anyway.
Yeah. Anyway, I'll give you feedback on that, but it's not an essay. That's the difference, isn't it? Why do they shut them down? Why can't they just log out? Go on. Yeah. Oh, cell and developmental biology. That's last year. Yeah. Rob? Oh no, you did that with Jenny Gunnison. The paper review is not easy, but that's the point is...
I guess it's teaching us a lot of skills. It's good to have the draft. That's the one thing I'm really missing you, the draft.
No, the draft is critical because the whole point is to teach you how to do this.
Because often we get a lot of feedback after we've submitted it. It's like, oh good, now I know how to fix this, and I can't resubmit it.
Yeah.
We're not going to bother because I'm not going to get marks for it.
Yeah.